Happy Monday. Today we're going to talk about solving rational equations. We have been looking at rational expressions for the last week. This is our last section of our last unit of the year, so this should be a special unit, right? So let's go ahead and get started. You're going to fill out your note sheets as we go through the video together. So again, this is rational equations. So the first thing we need to do is talk about what they are. So a rational equation is an equation that contains one or more rational expressions. We've been looking at the rational expressions. You've been adding them together. You've been multiplying them, dividing them, simplifying them. So today we're going to actually solve for the variable. So we have 3 steps to do that. The first one is multiply each term of the equation by the LCD of all the expressions in the equation. The LCD is the lowest common denominator. We've been calling it the LCM, the least common multiple. Same thing. Step 2, solve the remaining equation. And step 3, check all the solutions in the original equation. So when we multiply by the LCD, it will make all of the denominators cancel. So all of the fractions will be gone, and it will make everything so much easier to solve. And then when we check our solutions, sometimes we get an answer that just doesn't work in the expression. For example, it might make the bottom of the equation, or bottom of the fraction 0, and we know that we can't have a 0 in the denominator. So we call those solutions extraneous solutions. It's just a solution that does not work in the original equation. So here's our first example, and I am going to switch this over now to the document camera and work it out that way. So here's our example. So I'm looking at 1 over x plus 2 over t equals 17 over 18. So I am first going to look for the LCD or the LCM. So I'm going to come over here and I'm just going to write that. Well, if I look at 8t and 8t, it looks like if I multiply these two together, I'll get 8t. So it looks like the best option would be 8t as our least common multiple. So what I'm going to do next is multiply this entire equation by 8t over 1. Now watch what happens. If we distribute that to everything, we have 8t over 1 times 1 over 8 plus 8t over 1 times 2 over t equals 8t over 1 times 17 over 8t. So remember, just like when we were adding and subtracting, we always reduce everything we can at the very first step. That's what we're going to do here. So this 8 will cancel this 8. That leaves me t times 1, which is t. Then I move over here. This t will cancel this t. So I'm left with 8 times 2, which is 16. Then I have my equal sign. This 8t is going to cancel that 8t. And I just have 1 times 17, which is 17. So now I've taken this equation that had all these awful fractions, and I've turned it into something that is just a one-step equation. How do I solve this? How do I solve for t? I'm just going to subtract 16 from both sides. So there's minus 16 here and minus 16 here. And when I do that, I get t equals 1. So I'm always going to go back to my very original equation and put in t, plug in 1 for t. So I have 2 over t. So I have, let me write it down here. 1/8 plus 2 over 1 equals 17 over 8 times 1. Okay, well, this is already simplified. How can I rewrite 2 so it has 8 in the denominator? So that means I have to multiply this 1 by 8. So I also have to multiply the top by 8. So that would be 16/8 equals 17 over 8. Well, is that true? 1/8 plus 16/8 is 17/8, which does equal 17/8. So that's a good answer. So it's not an extraneous answer. It works. So t equals 1. Let's go on to example 2. So in example 2, I have 3x over x minus 3, and that equals 2x plus 3 over x minus 3. Well, in this case, both of my denominators are the same, so my LCM is going to be x minus 3. So I'm going to multiply this entire equation by x minus 3 over 1. So I get x minus 3 over 1 times 3x over x minus 3 equals x minus 3 over 1 times 2x plus 3 over x minus 3. So the good thing about this is this x minus 3 is going to cancel that x minus 3. So I'm left with 3x. This x minus 3 is going to cancel this x minus 3. So I'm left with 2x plus 3. So again, I'm just going to solve this equation. Let's get the x's all over to one side. So let's subtract 2x here and here. So I get x equals 3. So now the last thing I have to do is plug it into the original equation. So I get 3 times 3 over x minus, 3 minus 3 equals 2 times 3 plus 3 over 3 minus 3. So I just replaced the x's with 3. Well, 3 times 3 is 9. 3 minus 3 is 0. 2 times 3 is 6, plus 3 is 9 over 0, which they look to be equal. However, I can't have a 0 in the denominator of any fraction because that's undefined. So for, let me move that up. So for this equation, there's no solution because the one that we found doesn't make this true. So no solution. Let's look at example 3. Alright, so I look at my denominators. I have x, 6, and 6. So it looks like I'm going to have to multiply those together to get my LCM. So my LCM is going to be 6x. So I multiply everything by 6x over 1. So I have 6x over 1 times 1 over x equals 6x over 1 times x over 6 minus 6x over 1 times 5 over 6. So I go through and I cancel. So this x is going to cancel that x. So I'm left with 6 times 1, which is 6, over 1, and I don't have to write the over 1. 6 cancels this 6. I'm left with x times x, which we know is x squared. Then I am going to cancel this 6 with this 6. So I'm left with, this is a minus, so it's negative x times 5, or negative 5x. Well, this is a quadratic, so I'm going to get it equal to 0 and see if I can factor it. So I'm going to subtract 6 from both sides. So those 6's cancel, they leave me 0. I have x squared minus 5x minus 6. And I know you're going to love this part. We're going to do the box. So we come over here. We do our box. X squared goes here. Negative 6 goes here. I'm looking for factors of negative 6x squared that add up to negative 5x. So I have 1x and 6x, 2x and 3x. Those are all the factors of 6. Which one looks like it will give me negative 5? Well, remember, this is negative, so one of them has to be negative, one of them has to be positive. So if that happened down here, that would give me either positive 1 or negative 1. So it has to be this one. and the 6 has to be negative because I need negative 5. So remember, the diagonal has to add up to this term. So now I factor out GCF, so x plus 1, x minus 6. So I get 0 equals x plus 1, x minus 6. This is a good review for our quadratics that are going to be on the final exam. So remember now, x equals negative 1 or 6 because it's the value that makes either one of these equal to 0. So the last thing we have to do is just check it in our original equation, which is 1 over x equals x over 6 minus 5 over 6. So let's just think this through. The only way that it would be extraneous is if, well, let's just plug them in and see what happens. So we'll plug in negative 1 first. So I get 1 over negative 1 equals negative 1 over 6 minus 5 over 6. So this gives me negative 1. Negative 1/6 minus 5 more gives me negative 6/6, which is just equal to negative 1. So that one works. Now let's check 6. So that will give me 1 over 6 equals 6 over 6 minus 5 over 6. Well, that's 1/6. 6/6 minus 5/6 is also 1/6. So that works as well. So both of my answers work. So my solution is negative 1/6. And that problem's done. All right, example 4. Okay, well, this one is kind of like those addition problems we did yesterday. So my LCM is going to be the 2 multiplied together, so it'll be 2r and r minus 5. So I look at, I'm going to multiply the whole thing by that. So 2r times r minus 5 over 1. So that gives me 2r times r minus 5 over 1 times 1 over r minus 5 equals 2r r minus 5 over 1 times 7 over 2r. Now we cancel, that cancels that, and I have 2r times 1 left, so 2r. This 2r cancels that 2r, so I have r minus 5 times 7, which gives me 7r minus 35. All right, well, I'm going to subtract 7r from both sides. So that gives me negative 5r equals negative 35. So divide by negative 5. So r equals 7. So really what I want to look at is in this original equation, does 7 make either one of these denominators 0? Well, in this one it would make it 7 minus 5, which is 2. So that one would be okay. And 2 times 7 would be 14. So this is a good answer. So that's the answer we're going to use. So that's just kind of a shortcut way to check that. All right, let's look at example 4. So remember, this 4 is like 4 over 1. So I have 1, x, and 2x. So it looks like my LCM, the best choice would be 2x. So let's multiply everything by 2x. So 2x over 1. So I get 2x over 1 times 4 over 1 plus 2x over 1 times 1 over x equals 2x over 1 times 10 over 2x. And let's just cancel what we can. Well, nothing here, so that gives me 8x. This x is going to cancel that, so I get 2 times 1, so plus 2. This 2x cancels that 2x, so I have just 10 left. Okay, well, subtract 2 from both sides. 8x equals 8. Divide both sides by 8. X equals 1. Let's go back up and check it. This will give me 1. So I'd have 4 plus 1, which is 5. This would give me 2 times 1, which is 2. 10 divided by 2 is 5. So that answer works. So